Hello mga kabulero. I am going to experiment today to test if the image detection that I have selected is precise and effective enough to locate and detect my collection anime figures. And my selected image detection algorithm is the PFM or the point feature matching model. Before we proceed with the technicalities, let me first show you the images of my anime collection figures. I have taken this picture of each of the anime figure and removed the background after. So shout out to the sponsors of this action figures, Ate Marigold Novellero, who gave me the Naruto figures, and Engineer Renel Magliari, who recently gave me the Trunks figure. Now here's my collection. So the first character or the first few characters are the main characters of the anime series, Naruto. And of course, we have Naruto, our first image here. Second, we have Tsunade, Minato, Shikamaru, and this is my favorite character from the Naruto series since when I was in college. We have Neji, and now the succeeding characters are the complete members of the Akatsuki. So we have Itachi, Deidara, Hidan, Zetsu, Kakuzu, Kizame, Conan, Orochimaru, Pain, Sasori, Toby, and this one is the biggest among my collection. And this was the one given by Engineer Renel Magliari. And now this is the group photo of my collection. And the main goal of this experiment is to create a MATLAB code of the point feature matching model and see if it can detect the individual anime figure on this group image. So let's go ahead and show you the MATLAB code of PFM. I have two different codes here or tabs. The first one is this one is a shorter version, but I also have a longer version which it shows the feature extraction and also few more figures to show us what's happening at the background of this point feature matching model. So the only item or line item that we will be editing right here would be the first code for the reading the reference image and also the target image or the group image. So basically, what will be discussed for now would be the step-by-step process, but later on I'll show you how this is going to work. So the first line of codes here are or is for reading the reference image containing the object of interest, and that will be the individual anime figures that we will be selecting. All right. Next would be reading the target image containing a cluttered scene, wherein that will be our group picture of the action figures. Third would be detecting the feature points in both images, and that is using surf. And we will be discussing in the summary slide what is surf and what it does in our model. Next is extracting the feature descriptors at the interest points in both images. And that is the extraction of the outstanding features from our reference image or the individual anime figures versus and matching to the group picture. Now, we also display the putatively matched features, so it's like a matching analysis or process that's happening. Next is estimate geometric transform 2D calculates the transformation relating the matched points. We're eliminating outliers. So this is where the outliers and the inliers of the reference image are being checked on and also being indexed. All right. So here, the next line of codes would be the bounding box or the polygon and that is the bounding box that will appear right after the strong features are being matched from the reference to the group image. And right after that is the transformation of the polygon. And of course, since it's a polygon, we are expecting to see it as a rectangle or a square if it's if the features are found on a single space within our target image. And finally is the display of the detected objects. This is just to show us the figure that contains the bounding boxes, and including here at the very top is also a figure just to show us the reference image side by side with the target image. So I'm not going to discuss this further for all those interested of the code. I will be posting the code on the description box below. All right. So the first image that I have here for detection is the Naruto image. All right. So I have Naruto, and then the group image is this one, the one that I've shown from the previous slide. All right, and here is our reference image. This is the Naruto image, and this is the group picture or the group photo, including the bounding box. So this is a trapezoid that was created from the bounding box that connects the features that was extracted from our model. And that's for Naruto. Now let's use a different random character. So let's try my favorite anime figure, Shikamaru. And that's the file name of the image. Let's run the code. This is the reference image. And here it is. Okay. The bounding box is a bit huge, but you can find the target image or the reference image at the center of the bounding box. All right, pretty good. Pretty good detection. Now let's try a different one, maybe from the Akatsuki side. Let's try uh, Sasori. Okay, and of course, this is Sasori. And look at the detection. It's at the middle of the bounding box. Pretty cool. Actually, I have used this model on one of my projects, and later on in the summary section, I will show you the output of our of my project. So let's try another one. Let's try Kakuzu. I'm just picking at random. And this is Kakuzu. Oops. And this is the detection. And this is a bit messy. Look at the bounding box. It is across the entire image. So Kakuzu is here. It looks like the features are scattered all over the place or all over the image. That is why the bounding box looks like this. So I think that the model is not that accurate, given that there are some discrepancies or issues with other detections. So the let's try the last image for detection, and we can definitely have our summary slide for our discussion. Let's try Tandang Tsunade. And this is Tsunade. Pretty cute. And this is the group picture with a detection or the bounding box. Right? Pretty cool for the detection of Tsunade. Now, what I'm going to show you is a quick snapshot or summary of what we've done. And let's go back to our slide. Okay, so here is a quick summary on how the point feature matching model is done and what the process is behind. So looking at the image or the slide here, you will see that you have a Knorr broth cube, a Nescafe creamy white, and also a cluttered space, which includes several kitchen objects or things like a noodle, um, toothpaste, have oranges and lemon, and also we have Nescafe there. And later on, I'll show you how this project has been created or what is the output of this object model or object detection model is being done. And first, the other sample objects again that I have here is, or the main goal of this project is to detect the Knorr broth cube and the Nescafe Creamy White. But the first thing that we have done is the target image should be red as well as the cluttered image. And that was the line item or the first line of codes on our program. So the said images are converted to grayscale and showing the command RGB to gray. That is why what you are looking right now in my screen are grayscale images. So the algorithm utilized the speeded up robust features or SURF, and that's what I mentioned previously when I'm discussing the codes line by line. And that SURF method is there to compare the reference to the target image. And the outputs of the SURF of the detection of the feature points in the reference images would be the Knorr broth cubes, the Nescafe creamy white, and the target cluttered image. And the figure also displays the 50 strongest feature points in the reference and target images. And those are shown on the screen. And later on, I will show you the actual running of the code, the longer version of the MATLAB code. So after the feature points were extracted, the algorithm determined which points were considered as true and false matches. And the images here shown on my slide are the putatively matched points for the broth cube and for the coffee. So the image includes both the inliers and outliers, and notice that multiple yellow lines connect the feature points of the reference image to the match points of the subject on the target image. This looks like a matching type examination that we are doing when we were in elementary or in high school. And this is how the point feature matching model looks like when it is connecting or showing you the outstanding feature points which was extracted from the reference image to match the match points of the subject or the target image. Now, these are the matching point pairs with the outliers removed for the broth cube and for the coffee. And this figure demonstrated a clearer view of the match of the model or of the object in the target image. So earlier we have multiple yellow lines, now we have fewer and a more exact feature points matching of the model. And the final step is the transformation of the bounding polygon of the reference image into the coordinate system of the target image. And the image is the final output of the detection model. And since the PFM in nature uses grayscale images, the project that I have presented created or retrieved the RGB color of the target image to have a better appearance of the detected object in an RGB space, of course bounded by the colored rectangle in the cluttered scene. So before we end this presentation, let me go back to MATLAB and show you the longer version of the point feature matching. And this includes, or this will show us the step-by-step figures how the model is processing the information. All right, so let's not get this too long. Let's run the code. This would take a little bit longer versus the one that we've done previously because this is showing more figures compared to what we've shown previously. Okay, so here is the reference picture, right? Now we have this one. This is the grayscale of the group picture or the cluttered scene. Let's minimize this one. And this is the feature extraction. Now you can see several circles and also a plus sign at the center showing us that these are the strong features that was extracted using the SURF model or method. Next is the 50 strongest feature points from the scene image or our cluttered scene. And then what happens right after the strong features were extracted is this one, the match points, including the outliers. That is why there are several matches in the on other portions of the image, like this one, the data and other figures. But the strong features, look at Naruto here. The strong features are matching onto the multiple strong features that was extracted on the reference image. So the more features that was projected on the target image, that would definitely be the result when the inliers were only the ones which are being extracted or being matched. That's how it goes. And finally, this is the output of the point feature matching model. And that is it. This is a pretty amazing experiment. And since we have a good number of samples from our anime collection figures, this made it more interesting. So thank you so much for watching, and I hope you learned from this video. Hopefully, you will be able to apply these techniques to your project and create your own idea utilizing machine learning. See you again on my next video. Thank you so much.